In this video, we're going to explore how to find the total number of possible outcomes in a given scenario using either arrangements, permutations, or selections. This video will just focus on introducing the topics and what technique you use for what situation. The next video will demonstrate how to apply these concepts to exam-style questions. For those that don't know me, my name is Chris Ionadoni. I used to work as an engineer for a defense company, and I left that to start a career in tutoring. I make these videos now to help VCE students do the best they can in math methods. With that out of the way, let's get into it. Suppose you had a set of 3 different coloured objects, red, green, and blue. How many different ways could those be arranged? Well, the obvious approach is to just count the number of ways you could arrange them. And that's good for a smaller set of objects, but what if I want to know how many ways I can arrange 10 different objects? You can think of this by imagining that your 10 objects have 10 possible slots to be arranged into. So, how many choices do we have for that first slot? Well, I've got 10 choices because I have 10 total objects. How about for the next slot? Well, because I've already used one of my objects for that first slot, I only now have 9 choices for that next slot. And then, once again, I'm going to have one less option for slot 3. And this pattern will continue over and over again until you run out of slots. We can see that there were 10 choices made in sequence, and so the multiplication principle will apply. This is what's known as a factorial. This particular example can be written as 10 factorial. A factorial simply tells you how many ways n number of objects can be arranged into n number of positions. What happens when you have more objects available than you have positions for those objects? Like, for example, I have 10 new books, but only room on my shelf to put 3 of them on there. How many possible arrangements are there now? Again, you're just going to consider the available positions. There's 10 options for that first slot, there's 9 options for the next slot, and then 8 for the last slot. We've run out of positions, so this is where we stop. Again, this is choices made in sequence, and so we're going to multiply the number of choices in each stage. Okay, well, that works for easier examples, but what happens if I have a really large group size? There is a simpler way to generalize this for all number of group sizes. Suppose you have n objects, and you can make r choices from those n objects. The total number of possible combinations is thus given by the permutations equation. And if we apply the permutations equation to the previous example, we can see that it very quickly simplifies to just 10 by 9 by 8. It's worth paying attention how to simplify these factorials nicely. You'll notice that if you expand the numerator and denominator, there's going to be a lot of common factors that you can cancel out immediately. This greatly reduces the effort required to simplify these factorials. Not all scenarios are best described using permutations. One of the problems with permutations is that it considers the order of the objects to be important. For example, let's suppose we have 3 different options for ice cream: chocolate, vanilla, strawberry, and we're supposed to select 2 options from that list. Using the permutations equation, we find that there are 6 possible outcomes, but notice that we actually get duplicate combinations. For example, one of the combinations was vanilla then chocolate, but the other combination was chocolate then vanilla. We get these duplicate combinations. If we don't care about the order in which those flavors are scooped, then permutations isn't ideal for this. This is an application for selections. The equation is only slightly different. There's an additional division by r factorial to remove all of those duplicate combinations. Now, if we apply the selections equation to this example, we get an answer of 3, thus removing all those duplicate combinations. So, how do I know when to use what? And how does this tie into probability? Well, I'm going to recommend that you use the following framework. First, we have to figure out the total number of possible outcomes in the given scenario. This is where we have to decide which type of counting method to use. If choices can be repeated, just use the multiplication principle. This is because the permutations and selections equations assume that the number of choices is going to decrement in each stage. If you can make repeated choices from the same groups, then the multiplication principle is your best bet. If the choices cannot be repeated, but the order matters, then use the permutations equation. The typical examples of this tend to be numerical. Like, for example, suppose I have a bag of 3 numbers, 1, 2, and 3, and I'm going to select 2 numbers from the bag and arrange them in different ways to create unique numbers. How many unique combinations do I have? Well, because we want the numbers 1, 2 to be different to 2, 1, we're going to use permutations, since 12 and 21 are 2 different numbers. And finally, if choices can't be repeated and the order doesn't matter, then we'll use selections. The typical example here is when selecting groups of people. Like, for example, a team of Jill and Jack is no different to a team of Jack and Jill. If you use selections, those duplicate combinations will be removed. The next step is to figure out the number of combinations that meet our target probability. And again, we're just going to be using the guidelines from before to figure out which counting method is best for this particular question. It's worth noting that some questions don't play nice with any of the counting methods, and so when in doubt, you just go back to thinking in terms of slots. How many options do I have, and how many slots are there? Lastly, we're just going to divide the result from step 2 by the result from step 1. Because in step 1, we found the total number of possible combinations for our given scenario, and in step 2, we found the total number of times our event occurs. So all we have to do from here is perform the division and then simplify the fraction. In the next video, we will see how we can apply this framework to solve exam-style questions. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.